Hello everyone, Namaskar, Raj Krishna this side. So let's solve one problem from ordinary differential equation. It's a linear differential equation with a constant coefficient problem. So I haven't solved this type of problem for a while, but I already have a playlist on this. You can check that out. It has a lot of problem on this type. So you already know how to solve this type of problem. Whenever you get this type of problem, the first thing which we go is because your final solution will contain the complementary function as well as the particular integral. Okay, your final solution looks something like this, isn't it? Y equals to cf plus pi. So we need to find CF, we need to find PI. So for finding CF, you further need from here the auxiliary equation. And for that, you simply have to do one thing. You simply have to replace this D by M. So you will be getting M square plus 2M plus 1 and now equate it to 0. So when you will solve this, this is nothing but a square plus 2ab plus b square. So this will give you m plus 1 times m plus 1. If I write m plus 1 whole square can be written like this. This equals to 0. Now from this you will be getting two equal roots. So I am writing m1 equals to minus 1 and m2 is also equals to minus 1. Provided you have got these two roots, you can now proceed and write your complementary function. So because the root is repeated, so c1 e power m1x, which is minus x, plus c1 plus c2. So c2x, and again other one is also e power minus x. So we generally like it, write it like this: c1 plus c2x, and collectively because e power minus x is common, so we write it something like this. Okay, now comes the bigger problem to find the particular integral. So for particular integral for particular integral, what you have to do is particular integral is nothing but 1 upon f of d is operating on this e power 2x minus cos x, whatever is there. Okay, so I can rather break this into two parts. So that will be something like this: 1 upon f of d, which is d square plus 2d plus 1, being operating on e power 2x, minus 1 upon again f of d, which is d square plus 2d plus 1 operating on cos x. Now for cos x, I think it is cos x only. Okay, so let me check with the problem which I had been given. It was cos x only. I will have to check it. Yes, it was cos x. So cos x is there. So for cos x and e power x, we have different rule. What we do in case of e power x, we simply take the value of a, which is 2 in this case. Okay, and what we do is replace the d which is there by a and check whether it is not equal to 0. In case it is equal to 0, then we will have to further multiply by x, differentiate denominator. So let's check. So if you put 2 here, I don't think it will be, denominator is going to become 0. So here it will be 4 plus 2 into 2 again 4 plus 1, and you will write it as it is, minus. Here if you see, you will have to replace, in this case, d square by minus of a square. This is what you have to do. So here cos ax or cos bx type of problem you have. So here, as you can see, the value of a here is 1. In case of cos x, the value of, if you compare this to cos ax, if you are comparing it to cos ax, you are getting a as 1. So a square will be 1 square, which is 1. So you will have to replace d square by minus 1 in this case. So if you do so, you will get minus 1 plus 2d plus 1. So this will get cancelled and this will again be written as it is cos x. Now see what we can do. This is simply 4 plus 4, 8 plus 1, 9. So 1 by 9. This is e power 2x. Now this is 1 upon 2d, which I can simply take out. And 1 by d is similar as integration with respect to whatever variable you have. So here we have x, so integration with respect to x. So integration with respect to x of what? Of cos x. So cos x dx. Fine. So now 1 by 9 e power 2x is simplified. Now integral of cos x. Okay. So derivative of cos x is minus sin x, but the integral of cos x is sin x. So you will be simply getting 1 by 2 sin x. That's it. This is your particular integral. Now finally, if I say, so your y will be CF plus PI. So your y will be CF was C1 plus C2x e power minus x plus your PI, which is 1 by 9 e power 2x minus 1 by 2 sin x. So this is the final picture which I was going to show to you, all of you. So again, not that difficult, if I would say. Just if you know the rules properly, the rules for finding CF, the rules for finding PI, you are going to crack this question easily. Okay, so you just have to replace d square by minus of a square in case of sin ax or cos ax, and in case of e power ax, what all you have to do is just replace d by a and check if denominator would have been equal to 0. Then you simply multiply by x, differentiate denominator, and do it again and again till the time it doesn't become not equal to 0. Okay, so I hope it is clear to you now. This was doubt of some students, so I thought I would make the video on this. So that's it for today. Thanks again.